Continuity is an important concept in mathematics and is widely used in various areas of study, including calculus that we are studying, real analysis, and topology. Alright, so when you say continuity, we say that a function is continuous over or on an interval or some interval of the real number line if its graph can be traced without lifting the pencil or the pen that you are using from the paper. For instance, when you have a graph like this, maybe you have a graph like this and you have a function like this, right? If you start from maybe the end of this function and then you trace from here up to the other end and you don't have to lift your pencil, it means that the function is continuous. But let's assume that you have a function like this, right? You have a function like this. This is basically, you can say, piecewise function, right? And you are tracing from here and you get here, and then you have to lift your pencil or the pen and come here and go here. We see that the function is not continuous, right? We see the function is not continuous. That's in simple terms what a continuity means. So a function f is continuous at x equal to a if that particular function is continuous over that particular interval, and it is continuous at each point in line, right? So you come there from there. So these are some conditions for a function to be continuous, right? So for a function to be continuous, it means that f of a must exist. That is, the output at a should exist. For instance, when you have maybe y equal to 2x plus 4, and then they ask you to find whether this function is continuous, right, at maybe a value of 2, you can graph it to determine whether it's continuous or not by using what I was saying over here, right? Using what I was saying over here. But if you want to do it in an algebraic approach, one of the conditions is that f of a, so let's say y equal to f of x, right? F of a should exist. So that means that they are asking whether the function is continuous at 2. That means f of 2 must exist. So when I do the algebraic substitution, I'm going to get 2 times 2 plus 4, and this gives me what, 8. So this means that this condition satisfies it. So let's move to the second condition. The second condition is that the limits of that particular function must also exist. The limits of that particular function must also exist. So if the function is f of x equal to 2x plus 4, and you are finding the limits as x approaches 2, you can do the neighborhood analysis and you will see the number that it is approaching. But in this case, you can see it's a simple function, and we can do a simple algebraic substitution, finding the normal limits. And you can see that doing that substitution, you are going to get 2 times 2 plus 4, and then it will give us what, 8. So this means that the limit of the function as x approaches a is also exist. So the last condition is that the limit of the function f of x must be equal to f of a. So this means that when you satisfy this condition and you satisfy this condition, you need to just compare the two values. Are they the same? If they are the same, it means that the values, that particular function is continuous. So in this case here, the function value was 8, and then the condition 2, the function, the limit of that particular function also what, 8. So this means that the limit of f of x is equal to f of a, and therefore the limit is the same as the output. and we can say that the particular function f of x equal to 2x plus 4 is continuous at x equal to 2, right? It's continuous at x equal to 2. So this is some simple explanation about or how you can get to know whether a function is continuous or not. So let's look at the example, right? So the example 2x plus 3. So we are asking whether this function is continuous or not. We are asking whether this function is continuous or not at a value x equal to 4. So in doing that, you need to state your condition somewhere. For a function to be continuous, right, f of a should exist, right? The limit of the function f of x, right? The limit of the function f of x as x approaches that particular number, in this case, which is 4, must also exist. And finally, you need to check whether f of a is equal to the limit of what? F of x, right? So let's do the analysis here. So here the f of a is equal to, let me say, f of 4 equal to 2 times 4 plus 3, and 2 4 is 8 plus 3 will give us what? 11. So we are done with this. So finding the limit for the particular function, this function 2x plus 3 as x approaches 4, you can see that this is a simple function and we just need a simple algebraic substitution, and therefore the same thing, 2 times 4 plus 3, and that one also gave me 11. So let's check up the third condition. It's f of a equal to the limit of f of x. Yes, because here f of a is 11 and the limit of f of x as x approaches 4 is also 11. So in this case, we can conclude that this function is continuous at the point x equal to 4, and even in fact it's continuous at any point on the real number line. It's continuous at any point on the real number line. All right, so let's look at this example. So we are asking, is this function continuous? This is an example of a piecewise function. So we are asking whether the function is continuous at x equal to -2. Why or why not? Why are you saying that it's continuous? And if it's not continuous, why are you saying it's not continuous? Okay, to find out if this function is continuous at the given point, which is in this case -2, we must check out a condition or determine whether the limit of this function exists, and then we evaluate the function at -2 and then compare whether they are the same or not. So in this case, when we evaluate g of x, g of -2, what are we getting? When we evaluate g of -2, we are going to get a value which is what? 2. When we evaluate g of -2, when we evaluate g of -2, yeah, the limit of, I forgot to place the limit here. As x approaches -2. So the limit as x approaches -2, you can do that analysis from there, right? First of all, you need to check whether even the limit exists or does not exist, right? If you don't check whether the limit exists, you can't find the limit of it, right? If the limit does not exist, then what is the essence of finding the limit? So that's where the neighborhood analysis, doing from the right and doing from the left, must be very important. So at -2, this is an example of piecewise function, so remember. So doing the limits from the right, it means that we are going to take this particular function, because from the right, that means x is greater than or equal to -2. That means from the right we are picking values which is close to -2 from the right, and in this case this particular part of the piecewise function satisfies our distance. So in this case we are going to use this function to find our limit from there, which is x minus 1. So from the right, 2 from the right, so here it will give us -2 minus 1, which is what? -3. So doing analysis from as x approaches 2 from the left, as x approaches 2 from the left, since we are picking values close to -2 from the left, close to -2 from the left, it means that this particular function with the piecewise distance satisfies our condition, right? Because here is less than, right? So it's satisfied. So in that case we are going to use this particular function to determine our limit. So this is how piecewise functions work, right? In this case we have -2 over 2, here is the one right already, plus 3, and -2 over 2, so we are going to get -1 plus 3, which is equal to what? 2. So in this case the left-handed limit, which is this, and then the right-handed limit, which is this, both are not equal. Therefore, based on what we discussed over here about the existence of a limit, that condition does not satisfy, so there is no need to find the limit of it. And since the limit does not exist, it means that even when we place in the function value and it gives us a particular value, still now we will say that this function is not continuous, right? It's not continuous, and yeah, this piecewise function is not continuous. So the conditions are: you check whether f of a exists. Secondly, you check whether the limits exist, and to check whether a limit exists, you need to check for the right-handed limit and then left-handed limit. And I told you that for a piecewise function, for the right-handed limit, values will fall for the second one because the condition is x is greater or equal to 2, which is what the right-handed limit. And then for the x less than or equal to -2, which is the left-handed limit, that's where the condition is. So we will pick this function for that. So you do that and they don't give you an equal value, it means that the limit does not exist, and we can conclude from there that this function is not continuous because there is no way it's going to satisfy the conditions.